Welcome to AP Physics Podcast. This is question number 30 from Chapter 11. We have a student that's sitting on a stool, rotating, holding two 3-kilogram weights at 1 meter from the axis of rotation. We find that the moment of inertia of the student and the rotating stool by themselves are 3 kilogram meters per second, 3 kilogram meters squared. So I, the student, is equal to 3 kilogram meters squared. The angular speed before the student pulls their weights in is 0.75 radians per second, and then the student pulls the weights inward to a radius of 0.3 meters, and we're asked to first find the angular speed after the student pulls the weights in. Now, we know that from experience that the student will speed up, so our final answer should be greater than 0.75 radians per second. And we have to use conservation of angular momentum to figure this out because there are no net external torques. So our change in angular momentum is going to be equal to 0, which means our L initial will be equal to our L final. Now our L initial, that's our I initial times omega initial. And our I final is I final times omega final. And we know that omega initial is our 0.7 radians per second. We're trying to find omega final, so our question is, what are the I's? And we can't, unfortunately, just use the I of the student, because the student is not the only thing rotating. We have to use our moment of inertias of point masses, which are two masses on the outside. So our I total is going to be equal to the I of the weights plus the I of the student. Now the I of the student doesn't change at all, so our I initial is going to be the I of the weights. Now these can be considered to be point masses, so they are mr squared plus the I of the student. And now we have two of the masses, so we have 2 times 3 times 1 squared plus the I of the student, which is 3. So we end up having an initial moment of inertia of 9 kilograms meters squared. In the end, we have the same thing, our I final, that's mr squared again, plus the I of the student. And our mr squareds for this time, we still have 2 of them. They're still 3 kilograms apiece, but they are now at 0.3 meters. And so we end up being left with 3.54 kilogram meters squared. And as you plug that in over here, we take our 3.54, it goes right here. Our 9, it goes in this spot here. And so we're left with a 9 times 0.07, 3.54 times omega final. So we find our final omega to be equal to 1.91 radians per second. And luckily, 1.91 is in fact greater than our initial velocity, our angular velocity, which was 0.75. In part B, we're looking for the kinetic energy before and after. So the kinetic energy is kinetic energy rotational, which is 1/2 I times omega squared. So for the before part, we have 1/2. Our initial I is 9, and our omega is 0.75 squared. So our initial kinetic energy rotational is equal to 2.53 joules. And in the end, our final kinetic energy rotational, K rot final, is equal to 1/2, 3.54, and then in the end we're going 1.91 squared. So we end up getting an increase in our kinetic energy, which ends up being 6.44 joules. So we have an overall increase in rotational kinetic energy.